Look up at the night sky. Do it tonight if you can. Pick a clear evening, step away from street lights, let your eyes adjust and look up. You'll see thousands of tiny points of light scattered across the darkness. And almost everyone at some point in their life has had the same quiet thought. Those are stars. Little glowing dots, like pinpricks in a black curtain hanging out there in space. They look simple, obvious, direct. A star is a star. A point of light is a point of light. But here's the unsettling question I want to start with. What if almost everything you think you're seeing when you look at a star isn't actually there? What if the star you're admiring doesn't look anything like what your eyes are showing you? What if the very idea of a point of light in the sky is something your brain invents to cope with a deeper, stranger reality? Because when physicists say that stars are, in an important sense, an optical illusion, they don't mean that stars aren't real. They mean something far more interesting. They mean that what reaches your eyes is not the object itself, but a distorted, delayed, filtered story told by light, matter, motion, and your own biology. And once you see how that story is constructed, you never look at the night sky the same way again. To understand this, we have to start somewhere very familiar, with light, with seeing, with the ordinary act of looking at something across a room. Right now, if you look at your hand, you feel as if your eyes are simply registering what's there. Your hand exists, light bounces off it, your eyes catch the light, end of story. But even this everyday act already hides a trick. You never touch the object you see. You never directly experience it. You interact with a stream of photons that left the surface of your hand a fraction of a second ago, traveled through space, passed through the lens of your eye, triggered chemical reactions in your retina, and were interpreted by your brain. Already, perception is indirect. You're always seeing the past, even if the past is only a few billionths of a second old. Now imagine increasing the distance. You look across a football field, across a city, across the earth, the moon, the sun. Each time the delay increases. When you see the sun, you're seeing it as it was about 8 minutes ago. If the sun were to vanish right now, which it won't, don't panic. You'd keep seeing it peacefully shining in the sky for 8 minutes, utterly unaware that anything had happened. So even nearby cosmic objects are already ghosts of their former selves. Now stretch this idea further. Much further, to the stars. The nearest star beyond the Sun, Proxima Centauri, is about 4 light-years away. That means the light entering your eye tonight left that star 4 years ago. Some of the stars you can see with your naked eye are hundreds, even thousands of light-years away. And if you look at distant galaxies through a telescope, you're seeing light that began its journey before humans existed, before Earth had trees, before complex life crawled out of the oceans. So the first illusion is time. The stars are not now. They are memories, ancient postcards arriving late. But this is only the beginning, because even if we forgive the time delay, there's a deeper problem. Stars do not look like points, not physically, not remotely. Most stars are enormous spheres of plasma, vastly larger than the Earth. Some are so big that if you place them where our sun is, they would swallow the orbit of Mars or Jupiter or beyond. So why do they look like tiny dots? Your instinctive answer might be distance. They're far away, so they look small. That's true, but incomplete. The moon is far away too, yet it looks like a disk. The sun is unimaginably farther than anything on Earth, yet you can see its shape clearly. The difference is angular size, how much of your field of view an object occupies. Stars are so far away that their angular size is far smaller than what the human eye can resolve. Your eye has a limit, a kind of pixel size imposed by the physics of light and the structure of your retina. Anything smaller than that limit doesn't appear smaller. It collapses into a point. So what you see as a star is not the shape of the star at all. It's the smallest dot your visual system knows how to draw. Already the image is fake, or at least incomplete, but it gets worse. If you watch stars closely, you'll notice they twinkle, they shimmer, They dance. They change brightness and color subtly from moment to moment. Children are taught that stars twinkle and planets don't. Why? Because stars are so far away that they act like point sources of light, and that makes them exquisitely sensitive to another layer of illusion, Earth's atmosphere. Between you and the stars is a thick ocean of air. It's moving, it's turbulent, it has layers of different temperature and density. Light passing through it is bent, scattered, delayed, and scrambled. For nearby objects with extended shapes, these distortions average out. But for a point source, every tiny fluctuation matters. So the twinkling of stars is not something stars do. It's something our atmosphere does to their light. Astronomers learned this the hard way. Early telescopes showed stars as little disks, complete with fuzzy edges and rings. It was tempting to believe those were real, but as telescopes improved, the disks didn't get bigger. They got sharper. That was the clue. The disks weren't stars. They were diffraction patterns, optical artifacts created by the physics of light passing through a circular lens. Galileo himself struggled with this. He thought he was seeing the actual sizes of stars. He wasn't wrong because he was careless. He was wrong because the universe is subtle. This brings us to a crucial shift in thinking. When you look at a star, you are not seeing an object in space. You are seeing a pattern formed by light interacting with instruments. Your eye, your atmosphere, your brain. The star itself is not a dot. The dot is your visual system's way of coping with information that exceeds its resolution. And now we reach a deeper illusion, brightness. Some stars look brighter than others. The natural assumption is that brighter stars are closer or bigger or more powerful. Sometimes that's true. Often it isn't. A star can look bright because it's nearby, or because it's intrinsically luminous, or because interstellar dust hasn't dimmed its light, or because its spectrum happens to align well with your eye's sensitivity. Your eye is not a neutral detector. It evolved to see predators, fruit, faces, not stars. It's most sensitive to greenish-yellow light. Stars that emit more of that light appear brighter than stars emitting the same energy in red or blue wavelengths. So brightness is already filtered through biology. This is why astronomers had to invent artificial concepts like apparent magnitude and absolute magnitude. Apparent magnitude is how bright a star looks to us. Absolute magnitude is how bright it would look if all stars were placed at the same standard distance. When you make that correction, the night sky rearranges itself completely. Dim stars can turn out to be monsters. Bright stars can turn out to be modest neighbors. So the ranking of stars, you see, is not a ranking of reality. It's a ranking of appearances. At this point, you might feel slightly betrayed. Time-delayed ghosts, point-like illusions, atmospheric distortions, biological filters. But the most profound illusion is still waiting. Motion. Go outside on a clear night and watch the stars over a few hours. They seem fixed relative to one another, rotating as a grand dome around the Earth. For thousands of years, humans believed the stars were attached to a celestial sphere. The Earth sat still. The universe turned. It made perfect sense. It matched experience beautifully. And it was wrong. The stars are not fixed. They are moving at enormous speeds in all directions. Some are orbiting the center of the galaxy. Some are passing near us. Some are fleeing. But the distances are so vast that their motion is almost imperceptible over a human lifetime. Almost. With precise instruments, astronomers can measure stellar parallax, the tiny shift in a star's position as Earth moves around the sun. This shift is so small that for centuries it was undetectable, and its absence was used as an argument against Earth's motion. Again, the illusion was convincing. Even today, when you see a constellation, the pattern feels eternal. Orion has always been Orion, but that's only because you live at a particular moment in cosmic history. Run time forward or backward by 100,000 years, and the constellation dissolves, the stars drift apart, the picture collapses. So constellations are pure illusion, human imagination projected onto a temporary arrangement of moving suns. Now let's push even further. What is a star? Physically, a star is a vast sphere of plasma, powered by nuclear fusion in its core. Hydrogen nuclei collide, fuse into helium, and release energy according to Einstein's famous equation, E equals mc squared. That energy takes an astonishing journey outward, bouncing around inside the star for thousands or millions of years before finally escaping as light. So the light you see tonight was born in the star's core long before it ever left the star. Then it traveled across space for years, centuries, or millennia. Then it passed through dust clouds, magnetic fields, gravitational fields. Then it was distorted by Earth's atmosphere. Then it was filtered by your eye. Then it was interpreted by your brain. At no point did you encounter the star itself. You encountered a message, a delayed, processed, corrupted message. This is where the phrase optical illusion earns its weight. Not because stars are fake, but because the experience of seeing a star is radically different from the physical reality of the star. And here's a thought experiment to make this painfully clear. Imagine you had a magical camera that could detect neutrinos instead of light. Neutrinos stream directly from the core of the sun, barely interacting with matter. They pass through Earth as if it weren't there. If you could see neutrinos, the sun would look completely different. You would see its core directly. The sun you see with light is only its surface, a glowing skin. Now imagine a creature that sees radio waves, or X-rays, or gravitational waves. Each would see a different universe. The night sky would not look like points of light at all. It would be filled with jets, shells, bubbles, explosions, invisible structures connecting stars and galaxies. Which one is the real universe? All of them, and none of them. Reality is not what you see. Reality is what exists, independent of how it's measured. What you see is a projection, a useful, limited interface shaped by physics and biology. Richard Feynman loved this idea, not because it made reality mysterious, but because it made it honest. Nature is not obligated to be intuitive. She is only obligated to be consistent. And once you accept that, the illusions stop being disappointments and start being clues. The star looks like a point because light diffracts. It twinkles because air moves. It shines steadily because fusion is stable. It appears fixed because distances are vast. It seems eternal because human lives are short. Each illusion teaches you something real if you know how to read it. Even color, which feels so immediate, is deceptive. Some stars look red, some blue, some white. But color depends on temperature, motion, and relativity. A star moving toward you has its light shifted toward blue. A star moving away is reddened. Dust can redden light too. So color is a mixture of intrinsic physics and cosmic interference. By carefully untangling these effects, astronomers can measure stellar temperatures, velocities, compositions, and distances. The illusion becomes a measuring tool. This is the final twist. Science doesn't eliminate illusions. It weaponizes them. We learn how light lies, and then we calculate exactly how it lies. We learn how instruments distort, and then we correct for distortion. We learn how perception filters reality, and then we design machines that see what we cannot. The star as a point of light is an illusion, but it's an illusion that carries encoded truth. When you look up tonight, you are not seeing stars as they are. You are seeing the outcome of an extraordinary chain of physical events stretched across space and time, ending in a tiny electrical signal in your brain. That signal is not the universe. It's a message from the universe. And that, perhaps, is the deepest lesson. The universe is not obliged to present itself in a form convenient for human senses. The fact that we can decode it at all, that from flickering points of light we can reconstruct nuclear reactions, stellar life cycles, galactic motion, and cosmic history, is one of the great triumphs of human curiosity. So, yes, stars are an optical illusion, but they are the most beautiful illusion we've ever learned to understand. And when you realize that, the night sky doesn't become less meaningful. It becomes infinitely richer.